Let's talk about dynamic arrays. In programming, we may come across situations where we may have to deal with data which is dynamic in nature. The number of data items that will be used are sometimes still unknown during runtime, or sometimes changing. Such situations can be handled more easily by using dynamic memory allocation, where the memory is allocated and released at runtime. Arrays that are created during runtime are called dynamic arrays. In dynamic memory allocation, the same functions used for creating dynamic variables will be used in creating dynamic arrays, such as the malloc, and this allocates a block of memory given a size and returns a pointer to the first byte of allocated space. So how do we declare? Let's say a dynamic integer array. We start off with an integer pointer, let's say p, and then p is equal to int asterisk. So this is the data type of the pointer. And then we use the malloc function to create or to allocate space equal to n times the size of the integer, where n is the size of our array. The next function that we use is the free function that frees the previously allocated space. And to use that, we simply call the free function and pass the pointer as a parameter to it. Let's try and code this example. So I've saved the file as dinarrays.c, and we will start with our preprocessor directives. But right now, we will have two include statements. The first one is include stdio.h, and the second one is include stdlib.h. So we will be able to use the malloc and the free functions. Let's write our main function here. And then let's create a float pointer and name that grades. Then for our integers, we will have I, and then size, we initialize that to 3. So let's declare our dynamic array. We have our pointer, followed by float, asterisk, which is the data type of our pointer, and then malloc, size of float, here, and then we multiply that by size, which is the size of our array. Now let's try to populate our dynamic array. So let's use a for loop. For I is equal to 0, I is less than size, I plus plus. So let's prompt the user to enter a grade. Enter grade in subject %d. And then I plus 1. Then scanf %f ampersand grades I. And as you can see here, this is just like an ordinary array because the usage is the same. We are just putting the value at the address of grades I. Now let's try to print the grades. So let's just copy this for loop here. And no need for this scanf anymore. And we just simply change this to your grade in some subject D is percent F. And then this is I plus 1. And we need to write here grades I. After that, we need to free our array. So we just write here free grades. Let's put our return 0 here. And let's try to compile. Hopefully there are no errors. Sorry, I should have typed gcc dinarrays.c. And there are no errors. Let's try to output. So enter grade in subject 1, let's say 1. Subject 2, let's say 3. And then subject 3, let's say 2.5. And there we go. Let's just put the \n here so it's much more readable. Let's try to compile again. And then run the program again. 1, 3, and 1.25, for example. And there you go. So again, this is how we create single-dimensional dynamic arrays. We need to declare a pointer first, and then use the malloc function to allocate memory the size of your variable, and then times the number of elements of the array. And never forget to free your array after usage to release the previously allocated memory. So that's it for single dimensional arrays. The next videos will be dealing with multi-dimensional arrays. Thanks and goodbye.